Welcome to today's Explainer. Today, we're unpacking one of the absolute most fascinating mysteries in all of modern science. It's a topic that perfectly bridges astronomy, artificial intelligence, and philosophy. We're tackling a colossal question. Where are all the aliens? To really grasp the sheer scale of the cosmos before we even dive in, just consider this single fact. There are over 100 billion stars in our Milky Way galaxy alone. 100 billion. And orbiting those stars are billions upon billions of planets that scientists estimate could, in theory, support life. It's a staggering, almost incomprehensible canvas of possibility.
To put that into perspective, I want you to imagine walking down to the ocean, standing on a massive sandy beach, and looking down at your feet. Think about every single grain of sand just in the square foot around your toes. Now imagine every grain of sand on that entire beach. Now, zoom out and imagine every grain of sand on every single beach, on every coastline across the entire planet. It sounds completely impossible, but there are actually more stars in the observable universe than all of those grains of sand combined. And around a massive number of those stars are Earth-like planets sitting right in the habitable zone. The mathematical probability practically screams that life should be everywhere. We absolutely should not be alone.
Which leads us to a really obvious but incredibly profound question. If intelligent alien civilizations are as common as the cosmic math suggests they should be, why haven't we seen any evidence of them? This question launches us right into our cosmic mystery and sets the stage for the core contradiction of this entire explainer. We have this gigantic, ancient universe, practically overflowing with planetary real estate, and yet nothing.
That brings us to Section 1, the Fermi Paradox, or the cosmic contradiction. The sheer bluntness of this mystery is best captured by a question asked back in the summer of 1950 by the brilliant Nobel Prize-winning physicist Enrico Fermi. He just asked, "Where is everybody?" Legend has it he was just having a casual lunch with some colleagues discussing a recent New Yorker cartoon about flying saucers when he suddenly blurted this out. He did the rapid mental math in his head, the age of the universe, the number of stars, the time it would take a civilization to develop interstellar travel, and he realized that Earth should have already been visited by extraterrestrials millions of years ago. So where were they? So what exactly is this paradox? Well, the Fermi paradox is the contradiction between the incredibly high probability of extraterrestrial life and the complete, utter lack of evidence for it. On one hand, you have a universe that's been around for nearly 14 billion years, packed with billions of habitable worlds. But on the other hand, you have absolute zero proof of anyone else living in it. It's this massive clash between our statistical expectations and our actual observations. And when we say zero proof, we really mean it. Despite heavily funded SETI programs, that's the search for extraterrestrial intelligence, scanning the skies with massive radio telescopes for decades, what have they actually found? No confirmed alien signals, no alien spacecraft, no alien civilizations, absolutely no undeniable evidence that intelligent extraterrestrial life exists. The eerie silence of the universe is deafening. It's the ultimate cosmic detective case, and it leaves us asking, is our math wrong, or is something else going on? Let's move to Section 2, 6 Theories of Silence, where we'll investigate the suspects. There are basically 6 major theories that astronomers, physicists, and philosophers use to explain the missing aliens. They are, we are rare, the great filter, they're too far away, they're hiding, we're too early, and we're looking the wrong way. Let's break these down one by one, because each of them has massive implications for humanity. Okay, let's dive into Theory 1. We are incredibly rare. This concept posits that maybe the conditions required for life to not just start, but to evolve from single cells to complex organisms to an intelligent, technology-wielding civilization are just astronomical flukes. Think about everything that had to go right for you to be watching this explainer today. Earth might simply be one of the very, very few planets, perhaps the only one, where this incredibly fragile chain of events actually succeeded. In this scenario, the universe is silent because we won the ultimate, near-impossible cosmic lottery. But if we aren't a rare fluke, we run into Theory 2, which is honestly a much more terrifying concept, the Great Filter. This is the hypothetical idea that there's some evolutionary wall, some inevitable event or insurmountable challenge that destroys civilizations before they can become advanced enough to explore the galaxy. The chilling question this theory forces us to ask is the Great Filter behind us, meaning humanity somehow miraculously survived it? Or is the Great Filter still ahead of us?
What's incredibly sobering is what those great filters could actually be. Think about things like nuclear war, climate collapse, artificial intelligence going completely out of control, or sudden catastrophic asteroid impacts. Notice how 3 out of 4 of those are entirely self-inflicted by technological progress. The Great Filter theory shifts our perspective completely. It moves us from looking outward for aliens to looking inward in the mirror. It asks the uncomfortable philosophical question of whether intelligent life is inherently self-destructive once it unlocks certain technologies. Then we have theories of logistics versus intent. Theory 3 suggests aliens are simply too far away. The physical barrier of the universe's immense size is absolutely staggering. Even traveling at the absolute speed limit of the universe, the speed of light, it takes years, decades, or millennia to travel between nearby stars. They might be out there, but we are just isolated by the sheer vastness of space. Contrast that with Theory 4. They're hiding. Often called the zoo hypothesis, this suggests advanced, godlike civilizations are indeed out there, but they intentionally avoid contacting young, primitive civilizations like ours. They treat us like a protected wildlife preserve, observing us from a distance without interfering, allowing us to develop naturally. We're in the cosmic zoo, and the zookeepers have their radios turned off.
Next, we've got theories of timing and technology. Theory 5 suggests we're just too early. Yes, the universe has been around for almost 14 billion years, but the early universe was a violent place, filled with supernovas and deadly radiation. Maybe it took exactly this long for the universe to calm down and produce the heavy elements needed for life. In this view, humanity might literally be among the very first intelligent civilizations to arrive at the cosmic party. But look over at Theory 6. We are looking the wrong way. Right now, we scan the skies mostly for radio waves. But expecting a million-year-old civilization to use radio waves is like expecting modern humans to communicate via smoke signals, right? They could be communicating using quantum entanglement, directed lasers, or physics we haven't even dreamed of yet. We don't hear them because we just lack the right antenna.
Now for Section 3, Humanity's Future, and why the Fermi Paradox matters.
The crucial point here is that the Fermi Paradox isn't just a fun theoretical sci-fi thought experiment. It provides a vital, practical framework for understanding ourselves. It forces us to act like philosophers and look deeply at humanity's future and our very survival as a civilization. When we look up at the silence of the stars, we have to reckon with the existential risks of our own making, like artificial intelligence and climate change. It highlights the urgent necessity of space exploration to ensure we don't keep all our eggs in one fragile planetary basket. Ultimately, it forces us to define our place in the universe. Are we just a fleeting accident? Or are we the universe's rare, precious way of knowing itself?
Finally, Section 4. Are we truly alone? The ultimate conclusion.
I want to leave you with a final, provocative thought. Think back to the very beginning of this explainer, to those 100 billion stars and those endless grains of sand. With all of that immense possibility out there, have we simply not looked hard enough? Are we surrounded by a bustling, thriving galactic community that we just can't see or understand quite yet? Or, in all of this infinite expanding darkness, are we truly alone? It is perhaps the biggest question we can possibly ask, because the answer, whatever it is, fundamentally changes everything about who we are. Thank you so much for joining me for this explainer. Keep looking up, keep asking questions, and I'll see you next time.